scientific development in decades. Researchers at the European Organization for Nuclear Research, or CERN, have found a new subatomic particle, and they say it looks like the long sought after Higgs boson. But more research still needs to be done. Now, CERN's Director General Rolf Buhr joins us now live from Geneva, Switzerland. Welcome to the program, and first, congratulations.
Thank you very much. We are all excited.
Now, you've discovered a Higgs boson-like particle. Just how much more work do you have to do to confirm that what you've seen, what you have, is in fact a Higgs?
Well, I think we have a Higgs, but we don't know yet if it's really the standard model Higgs or if it's a brother or a twin brother of it. And for this, we have to investigate all its properties in very tiny detail. I cannot say how long it will take. It will take quite some time after the discovery of a particle to pin down its properties.
Now, you've said that this discovery has global implications for the future. What kind of implications?
Well, I think for the first time since quite a few years, or quite, I would say 1 decade or even more, we have now some indication in which direction the future particle physics experiments should go. So that means we know now what instrument we might need. We have just to finalize the way we have to rebuild an instrument. But we know now the direction we have to go. Beforehand, many directions were open. Now it points towards a certain direction, and that will have global implications because we have to see where to build such a new collider.
There seems to be so many question marks ahead. Now, you found the particle just in time. I understand that the Large Hadron Collider there at CERN is going to shut down for almost 2 years at the end of this year for an upgrade. What will the new super collider allow you to do in terms of particle research?
Excuse me, I didn't get the second part of the sentence.
What will the new super collider allow you to do?
Oh, it opens a completely new energy region because we will bring the collider to its full specification. That means we will nearly double its energy. And that opens a completely new window even beyond the Higgs boson. But it will also allow to study the Higgs boson in more detail. So it allows many different things. And this is why we have to do it, why we have to shut down for nearly 2 years. But then afterwards, we come back with full power, with even more power. And this is fascinating. Then we open a new window into the early universe. We are already having one, but we have only one small window. We open it larger, a bigger window.
Now, during the live webcast, there was loud applause and cheering there at CERN. Just how emotional are you and fellow scientists right now?
Well, I think I slowly start realizing that I have some emotions about the result. You see the last days were full of tension. How far can we go? What can we announce? And now today it culminated in a fantastic agreement between the two experiments, which is excellent because you should cross-check results. So you need 2 experiments to cross-check. That was done. They both come to the same result. And I'm starting to develop more and more emotions. So it's time that I soon go on the plane to the conference in Melbourne to calm down and to have a glass of champagne.
No doubt looking forward to that. And the Nobel Committee is no doubt watching your announcement very closely. Who deserves credit for the discovery announced today?
Well, I think many people deserve credit for today. A huge number of people deserve credit for today. And that is one of the crux of the Nobel Prize Committee. Today's big science is no longer single persons, it is really groups of persons. So maybe it's at some stage time to think about changing guidelines. Maybe.
Now, leading up to today's Higgs boson breakthrough, there was a bit of a competition between scientists at CERN and scientists at Fermilab in the United States. But you were able to identify and make this announcement of this Higgs boson-like particle first. What gave you the edge?
Well, I think the main thing between Fermilab and CERN is really that we are in competition, yes, but we are also in collaboration. Yeah, they helped us when we had problems. We help them when they have problems. It's a healthy competition, a healthy collaboration. You can call it co-opetition if you want. A new word, I know, but you could use it. And the results from Fermilab underline what we have found, because they are in a different way. The boson can materialize, so to speak, can show up as a picture in the experiments. That's different at Fermilab and different here at CERN. So they underpin our result. So I think it makes it stronger.
You know, there's a lot of exciting work ahead. You have to confirm that what you found today is in fact a Higgs boson particle. You have the upgrade of the Large Hadron Collider taking place at the end of this year. But from what you know right now, this particle that you've discovered, what does it look like, and does it have mass itself?
Oh yeah, it has mass itself. Its mass, I think it's 130 times the proton mass, roughly. Yeah, so it's a pretty heavy particle. Now, if I'm not mistaken, it's the second heaviest particle we know. Yeah, but it is a different type of particle. It's neither matter nor force, and that makes it so fascinating, so interesting, because it's the first particle of this type. So we are all looking forward to study it.
Well, thank you very much for sharing your discovery with us, and also for sharing your story with such clarity. I have to admit, I took only physics for poets in university, so it's very much appreciated from me. Rolf Ewer, Director General of CERN, joining us live from Geneva. Thank you.